All right, so we just talked about a sample proportion in chapter 8. So look at what's happening now. We are going to estimate a population proportion. Cool, right? So we're just taking that next level. We're leveling up here. So a point estimate, this is going to be a real important keyword for us here. Point estimate is the value of the statistic that estimates the value of the parameter. Now remember, back in chapter 1, long time ago, a statistic is based off of a sample. A parameter is based off of a population. So we did this, right? We already talked about this in chapter 8. Now we're going to use this statistic to estimate the population. So estimating a population proportion. We're just building on what we already know, right? Pretty cool, right? Yeah, I think so too. Glad we're all on board with that. The Gallup organization conducted a poll in which a simple random sample of 1,015 Americans aged 18 or older were asked, do you consider the amount of federal tax you have to pay too high? Of the 1,015 adult American survey, 458 said yes. Obtain a point estimate for the proportion of the Americans 18 and older who believe the amount of federal income tax that they pay is too high. All right? So that's what we're looking for here. All right, so let's do it. We are finding a point estimate of the proportion. Now, when we talked about proportion previously, we had p hat is equal to x over n, right? Same thing. This proportion, this one is based on the sample, but what is a point estimate? A point estimate is the value of the statistic that is based on the sample. So that's where this p hat comes in. We're not getting rid of it. It is hanging out with us. So we have 458 divided by 1,015. So 458 divided by 1,015, 3 decimal places. Hook me up. What do you get? I got 0.451. Is that what you get? Okay. So then this is, oops, I don't know why I have that equal sign there. 0.451. That is our point estimate. So that means we estimate the proportion of Americans 18 and older believe that the amount of federal income tax they have to pay is too high is this proportion. Do you see that? Okay, so let's write this up. We estimate the proportion of Americans (18 and older). Right? We always say that because then we say the adults, right, at that point. Believe, because they're the ones that are actually paying taxes if you have a job. Believe that the amount of federal income tax they have to pay is too high. Oops, they have to pay is too high is 0.451. Oops, doesn't look like much of a 5, does it? So about what, if we take this as to a decimal, from a decimal to a percent, it's about 45%, right? So whenever we talk about something like that, sometimes it's referred to as a percent, but we're talking about the proportion, and a proportion is always going to be as a decimal, right? So that's where that comes from. Cool, right? So about 45%-ish, so 0.451, almost half of those surveyed believe that it's too high. That's kind of how that plays out. Cool. All right, so look at this. Now we've got a couple other big pieces of So the point estimate is a big deal because we're building off of that point estimate, right? That's where we start. That's our middle. So if we're going to build a confidence interval, so a confidence interval for an unknown parameter, right? Unknown parameter. So unknown here based on the population consists of an interval of numbers based on a point estimate. It's built off of that point estimate. So what actually happens is I have a point estimate and then plus or minus a margin of error. So our margin of error is saying, okay, so my point estimate is here in the middle. I'm going to go up a positive margin of error, and I'm going to go back a negative margin of error with that p hat in the middle. That's what that means. Positive margin of error, negative margin of error with my point estimate in the middle. That's a confidence interval. And we're going to really dive into that more. So right now we're just getting the basics, but we're really going to dive into that confidence interval. All right, but let's just get some vocab down so then we can work with some of this a little bit. Okay, a level of confidence represents the expected proportion of intervals. Expected proportion of intervals. I ran out of room there, didn't I? That will contain the parameter if a large number of different samples is obtained. If a large number of different samples is obtained. The level of confidence is denoted by 1 minus alpha. Remember, there's that alpha times 100. Okay, let's talk here for just a second. If I'm looking at a level of confidence, represents the expected proportion, okay, that will contain the parameter if a large number of different samples is obtained. Did we not just talk about this? That law of large numbers. The bigger these samples and the quantity of these samples that are taken, all of that is going to make it to where we can come up with the parameter. And I'm going to be a certain amount confident that this sample is going to represent my parameter. That's what that means. All right. Okay, let's do a quick little review here of the sampling distribution of p hat, right? We just went over this. So in this last chapter, let's review what we know about the model that describes the sampling distribution. So remember, there are criteria that have to be met. Criteria number 1, the shape of the distribution is approximately normal. Well, how do we know that? It has to meet that criteria, and it has to be no more than or less than, right, 5% of the population size. So in order to get normal, you have these 2 criteria that have to be met. Right, okay. What else do we know? The mean is the proportion. The standard deviation of this distribution is given by this formula, right? We just worked with those. So we're taking previous information and putting it into the current lesson. That's kind of what's happening here. Okay? And then here's a visual representation of what that is. So here we have our bell curve. 95% of this. So remember with the empirical rule. So with the empirical rule, we said 2 standard deviations was 95%. So 2 standard deviations away. Look at this number, 1.96. So with the empirical rule, we make a really good guess and we make it easy to work with. Now we're going to dive down and get real specific. The empirical rule works great if I'm talking in these generic terms as generalization. Now we're going to dive into real specifics. Look at this, 1.96. That's dang close to 2, isn't it? Yes, that is crazy close to 2. But this is actual specific content. So instead of with the empirical rule, it's 2 standard deviations away. Technically, it's 1.96. We just call it 2 because it's easier to work with. All right. Okay. So 95% of the sample proportions are within 1.96 standard deviations away. That's what that's looking at. So the margin of error for a 95% confidence interval is 1.96, which we know 95% here with the empirical rule was 2 standard deviations. This is just being more specific with the 1.96. All right. So this is what it's saying. Here is my point estimate here in the middle, and here is my margin of error. So if I am 95% confident, here's my confidence level. I'm 95% confident. I'm starting with the middle, and then I'm giving myself a cushion here of these 2 standard deviations. That's what it's talking about. So based on my data, based on the sample that we have going, we are going to have it contain the parameter. Based on the sample, we're going to determine the parameter, and we will be a certain amount confident. And if we're talking 95% confident, that's how we work with a margin of error. All right. So it's all starting to tie together here.